Anybody hear any good jokes lately? I feel like with all of our Zoom meetings, like there's a need for like good jokes. Did you have one you were going to share? Or you just like, I wish. So I heard one at our undergraduate research symposium. You may have heard this before. Does anybody know what you call a deer with no eyes? No idea. Do you know what you call a deer with no eyes and no legs? Still no idea. You can try that one out, you know, at Thanksgiving or something. I don't know. Nobody's got any jokes better than that. Uh-oh, we're in trouble. We're in trouble. That joke was thanks to Dr. Eggers. So you can thank her for that when you get a chance. So here we are, the last day of the semester. We made it all through in person, so just again, good job to everybody for following the guidelines. And I know this has been a stressful semester for everyone, and I just really appreciate everyone sticking through it and doing what you needed to do. And again, I think this is a time in all of our lives that we're going to look back on and be like, you know, I learned a lot from that, you know, whether it's like persistence, flexibility, whatever it is, you know, but I just think y'all should give yourselves a pat on the back at some point for being able to do everything that we were asked to do to stay in person. So that was really great. As we saw other colleges and universities going all online, we were able to keep it together. So good job. I just really appreciate every one of you and your effort and commitment to being able to do that. So thanks so much. So we've got our final exam coming up on Friday, so 11:30 a.m. To 2 p.m. I don't anticipate that it'll take that whole time, but you have that much time. It'll be in this room again, as always. There's one final article on Moodle that says to read it for the final exam. It's an article that addresses this idea of scientific consensus on climate change, you know? That, like, we might hear people say that, you know, climate change is not due to human activity. And there are people that believe that, and that's fine. That's absolutely fine. But that when we look at the consensus opinions held by scientists that study climate change, it's pretty clear that human activity is behind it. We can only explain the patterns we see now if we take human activities into account. But this article does a great job of just kind of laying that out, and it's written for a lay audience, so not too technical. The final thing I'll say is about our celebrations of knowledge. We have not hit the number that I had put on the syllabus. So what I'm going to do is I'm still going to drop your two lowest. So as of today, I'll have all those up on Moodle. So just take a look on there. I'm going to drop your two lowest. So in other words, they'll all be there on Moodle, right? But of those there, I'm going to drop the two lowest. Then I'm going to take the percentage of points that you have, right? And then I'm going to give you that percentage out of 100. Because if you remember, our celebration of knowledge grade at the end of the semester is equivalent to an exam grade, right? 100 points. So if we've only had 80 points, but you got 90% of those 80 points, you're going to get 90 out of 100 on that. Does that make sense? So I'm going to take whatever percentage points you got after I drop your lowest two quizzes and calculate that out of 100, and that's what you'll get for that segment of your grade. So again, after today, take a look on Moodle, and if there's anything there that we need to address, let me know. I've kept all the hard copies of those, so if you have any questions about any of them, we can look those up. Yeah?
As far as that final exam goes, is that a 2.5 hour block where we have 2 hours to take the exam? Or is that just a straight 2.5-hour block that we have to take the exam?
It's 2.5 hours, yep. Just you have 2.5 hours to take it. And as I mentioned this, I think in a review session, our exam is 1.5, our final exam is 1.5 times our midterm, because it's 150 points, whereas our midterms are 100. So you should have more than enough time. Like if it took you an hour to do the midterm, like it shouldn't take you over an hour and a half to do the final, if that makes sense.
And is that one, we could move earlier by chance?
So I think I emailed you, I know you'd emailed about taking it early.
This one, the one that's supposed to be Wednesday. Now I'm very confused.
No, this is the final exam. If people have talked to me about taking it early, then you won't need to take anything on that Friday.
Okay, never mind.
Yeah, so a few of y'all have emailed about taking the exam early, and if I said, yeah, come at this time, we can make that happen. There are a few folks coming Wednesday at 11, around the middle of the day. So if any of y'all would like to take it at that time, we're gonna have a group of students doing it then. Just let me know as soon as possible. If there's another time you'd like to take it early, again, I realize that's the last day of finals, so if all your other stuff is over and you want to get headed out a little bit early, I try to work with folks on that. So just email me, let's say by the end of today, all right? If you want to take it early, just so I can make sure the times are lined up, just let me know by the end of today if you'd like to take it early. Okay, yeah?
So I'm just confused as to why we're not taking it on our exam day. Like on the one, like this week?
Well, so final exams is a little different. Like, there's a different schedule for all the classes.
It's got the wrong date on the slide. That's what I was confused. Because they're taking November 20th.
Oh, that's so strange.
Okay. Yeah.
I apologize.
That's why I was really confused. I was like, why is there an extra one? Because I was like, I'm gonna have to work things around.
That is so strange. You guys, I apologize. You know what I did? I had the final exam slide from last semester. I changed the time and I changed the day, and I forgot to check on that date. Yeah, sorry about that. I don't know what I was.
So it is November 20th.
It is November 20th. I'm sorry. I can't believe I did that. Anyway, okay, yes. This Friday. Okay. Sorry about that. Thanks for pointing that out. All right. Any other questions or mistakes that I made on this particular slide? Yeah, sorry about that. Yeah, so Friday. I'm sorry. Thanks for pointing that out. Yeah. Okay. All right. Anyhow, moving on. Hope I have no more mistakes on this slide. But yeah, sorry. So let me know by the end of the day today if you want to take it early, okay? All right. Okay, gosh. Awesome. So last time we were talking about conventional energy alternatives to fossil fuels, and this idea that, if we're going to move from fossil fuels, we're not going to be able to switch immediately over to perpetually renewable options. And so we talked about things like biomass, nuclear, and hydro that combined are already producing almost 20% of the world's energy, right? So these are sources that we could use to get away from fossil fuels sooner rather than later. And they're not perpetually renewable. They're what we would call potentially renewable, depending on how we use them. So today we're going to talk about those perpetually renewable resources. And so these resources are currently only providing about 10% of our global energy. So, not a big chunk of it right now, but these are the fastest growing energy sources. So these are sources that we would expect in the future would be able to provide a fair amount more energy than they do right now. Cool. So this is a graph I think we looked at the other day, looking at installed capacity. And one thing that you notice, so we're going from 2000 to 2014, this dark blue is hydro. It was almost all of the renewable energy at the turn of the century. But now in 2014, we see that wind energy in the blue and solar in the yellow here has grown quite a bit more even than hydro. So, we've gone from 800 to from 800 to about 1,800. So essentially, more than doubled the installed renewable energy capacity globally of these. And it does include hydro, which we talked about as being potentially renewable, but across the board, fair amount of potential. If we look at just how much has been added, that shows even more clearly that wind has been growing quite quickly, and then solar following up. Solar in the last 10 years or so has really taken off. Wind capacity, you're going to see a lot of graphs like this today. Wind capacity has been increasing quite dramatically. There are almost, what are we at, like almost 15 times as much installed wind capacity in 2012 as there was in 2000. So incredibly fast growth. So these are sources that are only at 10% of our global energy, but they're coming online fast. If we look at solar, it's even more dramatic. We're going from 3.7, I think we looked at this the other day, going from 3.7 to up over 100, so that's an increase of over 30 times in an 8-year period. So pretty massive increases in both of these capacities. Now, what's interesting about technology is that as we do more and more of it, we get better and better at it. So this is a graph of what's called the Swanson effect. The Swanson effect has to do with the idea that every several years, the price of photovoltaic energy is cut in half, right? So if we're looking at, so we're in the 70s here. The 70s, it cost $76 per watt of energy. I know it's hard to see back there. $76 per watt. All right, 2 years later, it was at about half of that. Right? Again, 3 years later, about half of that. So nowadays, it costs about 74 cents to produce a watt of energy from photovoltaic solar, as opposed to $76 when it was first being developed in the late 70s. Okay, so that's over a time period of about 40 years, the cost of photovoltaic energy has become 1/100th of what it was initially. So the point to make here is that people will say, you know, photovoltaic energy, solar energy is very expensive. It used to be. But it's dropping so rapidly that now it's finally to the point where it's comparable with other sources of energy. And just the scale, right? Like you walk outside, you feel the sun on your face, and it's kind of mind-boggling how much energy comes to the earth every day from the sun. So the sunshine that falls on Texas in 1 month contains more energy than all the oil that has ever been pumped in the state. So massive amounts of energy here if we can just harness it. Yeah, Abby.
So is this Swanson effect talking about solar energy?
Yeah, thank you for asking that question. The Swanson effect is specifically for solar energy and how we see this it's basically saying within 5-year intervals, the price is being cut in half. Yeah, thank you. I didn't finish that thought. So the Swanson effect is this idea that within 5-year intervals, the cost of producing energy from photovoltaic cells has been cut in half. And that's largely due to technology improvement.
Within 5-year intervals, what?
Within every 5-year interval, the price is being cut in half. So if that holds true, then 5 years from today, it could cost half of what it is today again. So the idea is just that there's this massive decrease in cost. So we talked the other day about solar thermal electricity production. Remember, we watched that little video about concentrating the sun's rays to heat up salt, and then that heat is used to produce steam, which turns a turbine to generate electricity. So the kind of solar cells that you see on folks' homes work a little differently. They work by capturing the energy of the sun and using the energy of the sun to excite a flow of electrons within a medium. So literally, directly, you know how plants take the sun's energy and use it to move electrons to higher energy levels. And it starts this cascade of chemical reactions that generates ATP, right, which is energy. So you can think of photovoltaic solar cells as kind of working like human-made plants. And a little video to show that will hopefully explain it better than I can. But it's a different deal because it's harnessing the sun's energy, not just the heat of it, but what we call the photons, these tiny little packets of energy that come through the sun's rays, and using those to excite individual electrons. This is how it works. I hope our volume is still okay on here. Sorry.
The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the 2 types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles, called photons, shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the n side, while the hole is drawn to the p side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades. So what's stopping us from being completely reliant on solar power? There are political factors at play, not to mention businesses that lobby to maintain the status quo. But for now, let's focus on the physical and logistical challenges. And the most obvious of those is that solar energy is unevenly distributed across the planet. Some areas are sunnier than others. It's also inconsistent. Less solar energy is available on cloud. Reliance would require efficient ways to get electricity from sunny spots to cloudy ones, and effective storage of energy. The efficiency of the cell itself is a challenge too. If sunlight is reflected instead of absorbed, or if dislodged electrons fall back into a hole before going through the circuit, that photon's energy is lost. The most efficient solar cell yet still only converts 46% of the available sunlight to electricity, and most commercial systems are currently 15 to 20% efficient. In spite of these limitations, it actually would be possible to power the entire world with today's solar technology. We'd need the funding to build the infrastructure and a good deal of space. Estimates range from tens to hundreds of thousands of square miles, which seems like a lot, but the Sahara Desert alone is over 3 million square miles in area. Meanwhile, solar cells are getting better, cheaper, and are competing with electricity from the grid. And innovations like floating solar farms may change the landscape entirely. Thought experiments aside, there's the fact that over 1 billion people don't have access to a reliable electric grid, especially in developing countries, many of which are sunny. So in places like that, solar energy is already much cheaper and safer than available alternatives like kerosene. For, say, Finland or Seattle, though, effective solar energy may still be a little way off.
Any thoughts or questions? So what are some of the, it's when we think about renewable energy, it's this idea that different solutions are going to work well in different areas. What are some areas that solar energy might work really well in versus places where it might not work as well in? Any thoughts? Mm-hmm.
Deserts and flat plains probably are better, where there's less like obstruction of sunlight without trees and such.
Yeah, absolutely. And a lot of those deserts are close to the equator as well, which receives the most intense sun's rays. Yeah. What about some places where solar might not be the best solution to provide energy?
Is it like Antarctica, I think, where they have like days where the sun comes up like
Right, yeah, right. So places, yeah, exactly. Because the poles at certain times of the year, will have like hardly any sunlight at all. Yeah, so like that's a good example. And like that's one of the big challenges is the variation in intensity of the sunlight. So like this video didn't talk about it, but like developing really effective batteries is a really important thing. So that like when there is lots of sunlight, you can capture the energy and store it, and then use it when it's not. So yeah, places that don't receive a lot of sunlight, I mean, and they mentioned like Seattle, like there are certain places that have more than others. But it's really interesting what they said about developing countries too, because like here in the States, like we already have like coal burning power plants and things that like it's hard to switch off of. But if you don't have all of that, and like you're kind of investing in like initial energy infrastructure, then it might make more sense to go solar because it's more decentralized, When we were in Nepal, like in Kathmandu, probably the majority of houses have solar panels on them, right? So they're just creating their own energy individually. Cool. So they talked about the area of the planet that we'd have to cover in solar panels to get all of our to meet all of our energy needs by solar. And so this was a scenario that some folks had come up with location and area of solar farms that we could then use to meet all the region's energy needs. And I don't know if you can see them, but these little squares, let me just these lights for a second here. The other ones. But these little squares, these sort of pinkish yellow squares, represent the area that would have to be turned into solar farms that could then produce enough electricity to meet the area's energy needs. So you can see, I mean, they're pretty big chunks of space, and they calculate this based on the energy available. So like, up here in Northern Africa and here in Saudi Arabia, lots of intense energy. Here near Delhi in India. So these little spots, like if we were to do that much in the way of solar farms, like that'd be it. That'd be all our energy right there. Yeah, Abby.
They were talking about in the video that like the Sahara Desert gets so much sunlight, and if they like have converted that into like a solar farm, it could power like the world or something. But wouldn't that be destroying an ecosystem as well? Because the desert is an ecosystem, so like basically converting that land into a solar farm would probably be causing another problem.
So that's a good question, right? Wherever we're going to develop this, we're going to be affecting that ecosystem to a great extent, because it's not just the solar panels, it's the transmission lines, it's all that kind of stuff. So yeah, this will definitely have a big impact. And that's the thing about energy. Like, there's no silver bullet that's going to solve everything and have no negative impacts. I think the argument goes, if climate change is really what we're most concerned about affecting our globe moving forward, then solar is one way to do that, and hopefully we could do it in a way that we could minimize impacts to these ecosystems. Like in the Sahara, there are lots of places in the Sahara where things just can't live because it's too harsh, right? So if we can build them there, that would be best. But, it's going to take transmission lines to get this energy everywhere. So there are going to be impacts, But anyway, this at least is like a carbon-free way of doing it that would also get around some of the other negative impacts of coal and nuclear and all that. So all these energy sources have costs and benefits, but the ones that are perpetually renewable, these are things that we're not going to run out of. These are things that have sort of minimal environmental impacts, thinking of like the global impacts of climate change versus localized effects in the desert. But it's a good point. We certainly have to think about how to do it. Just a little bit about what the video was talking about with like the sun's intensity, different parts of the world. In the US, for instance, the southwestern US, very high solar intensity. So this is a place where it makes sense to really go heavily with photovoltaic cells up here in places like Seattle, fewer kilowatt hours per square meter potential. So again, there are some places where we should go first for solar, right? It seems to make sense. All right. So wind energy, second of our, there's a question.
Just wondering if, like, Texas gets like so much sun and all that. If you get like solar energy in Texas, can it only be used like in Texas?
That's a really good question. Yeah, so that's the thing is we'd have to send it other places with transmission lines, and transmission lines are really inefficient. They lose a lot of electricity. So there's a figure I used to put up, which I don't anymore, and it shows where all of our energy goes. And like, if you have a solar farm that generates electricity and it sends that electricity hundreds of miles away, you can lose as much as a quarter of that electricity just lost out of those transmission lines. So you're right, we can only send it so far, and then we lose a lot of it. So that's why really, we're going to have, maybe real intense in solar over here, maybe other sources here. So transmission, we're not even going to talk about transmission, but that's a real important thing to think about because we do lose a lot of energy from transmission. Yep. So wind energy really took off at the end of the 20th century, and it's funny, we're talking a lot about Texas today, but when we lived in Texas, you could request a certain percentage of your energy to come from wind energy, and it was almost the same exact cost as like the regular utility energy, like coal burning, because it has been developed so much out there that it's very, very cost competitive now, which kind of makes sense. So here's a similar graph to the one, similar figure to the one for solar energy, looking at wind energy potential, right? So these darker colors are places where the wind speed is higher. And so, where is wind speed generally highest across the US? Midwest, yeah, absolutely. Midwest, and then even up into the Rockies a little bit. So you can see some areas in Texas, right? So Texas, again, a wide open area, and a lot of ranching going on, so lots of open land with cattle moving around on it. You can put a wind turbine in there and it doesn't even take up that much space. And so it was really efficient to do this out there. So you can see, right, this area in the Midwestern United States has a lot of potential for wind energy. So maybe here is where we focus more on solar, Maybe here it's more wind. And you can see there's some areas, you know, mountainous areas. So there's some areas in the southern Appalachians with a little bit higher potential, but not as much as is out here. So again, this idea that like different renewable energy solutions are going to work better in different places. So we've got all these different sources of energy. We've got hydropower, we've got coal, oil and gas, wind, nuclear, photovoltaic, solar, geothermal, all these different things. And we can look at which of these have the highest energy return on investment. That is, every one of these requires energy to do, right? If we're going to burn coal, we got to go mine the coal, bring it over, burn it. If we're doing wind, we got to build the wind turbines, we got to install them. All this stuff takes energy. Which do you think of all these sources has the highest energy return on investment? Any thoughts? And I know we discussed this just a little bit the other day. We talked about hydro, yeah. So hydropower has the highest energy return on investment, almost twice that of second, which is coal burning for heat. Coal burned for electricity is a lot lower because we have to turn turbines and stuff like that. So, isn't it? So here, remember we talked about the tar sands, right, up on the Athabasca River. That's really, really low, right? You have to put a lot of energy into getting oil out that way. Biodiesel also is pretty inefficient. Why might biodiesel be so inefficient? Any thoughts? Yeah, it requires a lot of land, right? It's a lot of land, a lot of fertilizer, a lot of inputs. So our energy return on investment, hydro, is really super high. And again, this is energy from coal. Usually what we do with coal is we generate electricity, right? So really this is probably what we should be looking at for coal. Nuclear is kind of up there, but really hydro is you know, far and away the winner here. So that's getting at like efficiency, right? Well, we can look at carbon intensity as well. How much carbon dioxide is required to produce a kilowatt hour of electricity? And so similar thing, a couple different categories here. We've got hydro, ocean wind, nuclear, biomass, a couple different kinds of solar, like the thermal and the photovoltaic, geothermal, fossil fuels. This is probably going to surprise nobody, but the carbon intensity of coal is much, much higher, right? So again, like fossil fuels are kind of in their own category when we look at carbon intensity. So I don't know, I'm a stream guy, right? I study rivers and streams, I study fish. There's a part of me that doesn't like building a dam on a river because it's going to affect the life cycle of those species. But if we can find a way to minimize those impacts, hydro's looking pretty good, right? Because it's really efficient and it has almost as the lowest carbon intensity of any of these other methods. And so wind, quite low. Nuclear, remember we talked about nuclear compared to coal and like the climate change implications and just how much lower nuclear is. Solar photovoltaic, a little bit higher because we have to mine those rare earth minerals, have to do things like that. But again, it's an order of magnitude lower than natural gas, which, and this is kind of an important point here, natural gas has less than half the carbon intensity of coal. And that is why when we've been converting our power plants from coal over to natural gas, it's led to this decline in carbon emissions in North America over the last 10 years or so, right? Because of the fossil fuels, natural gas has the lowest carbon footprint. Okay, so you see we have these two things we have to balance, right? We have to balance which way of getting energy is most efficient. And then again, the reason we're really talking about getting off of these is because of the changing climate. which, by the way, you might have heard, the current hurricane season is the most hurricanes of like any hurricane season ever this year. And that's predicted through climate change because when water is warmer, those storm events become more likely. So again, climate change is this thing that affects so many things in so many ways. So if we want to try to lessen those impacts and severity, getting off of these three is really a goal. So looked up some stats. You know, folks will talk about jobs, and they'll say, well, you know, we can't switch over from coal, oil, or fossil fuels to renewables because there are people that are working in those industries, which is certainly true. But recent stats show that there are right now 3 times as many people working in clean energy as in fossil fuels in America. These are data from 2019. Because again, right, when we're mining coal, it's not a whole village going out there with little pickaxes anymore, right? It's these massive machines that there's somebody, you know, operating a computer somewhere that's working it, right? So really, when we look at jobs and job growth as well, renewable energy is really kind of where it's at. So, so that argument just really doesn't hold true anymore. Data from the EIA, the Energy Information Administration. That's from. Okay, if we look globally, solar photovoltaic is providing the most jobs. Across the board, there were 11 million people employed globally in renewable energies as opposed to 9 million just 2 years before. So again, it's a sector that's growing, that's providing more jobs for folks. And solar, biofuels, and hydro, and then wind look like they're employing the most folks around the world. Cool. So that's our conversation about energy. It felt a little brief, but to be honest, the questions aren't that complicated. It's just part of the political reality of changing things over, which makes it very complicated. And so we've seen the numbers. We know that this conversion towards renewables is happening. We know that it has to happen because we're not going to have fossil fuels for that long. The only question now is kind of how it happens and when it happens. With technology making solar cheaper and cheaper, wind already being comparable to fossil fuel produced electricity, the arguments are starting to fade away. And so, you know, and it couldn't happen any sooner, right, as we're starting to see more of these impacts of climate change. So we need to kind of keep pushing, keep bringing these things to the attention of our political leaders, and then at the same time having conversations with our friends that, you know, revolve around data and what's actually going on. Okay, so I wanted to just touch a little bit on waste management. It was the last topic we're going to get to this semester, and so I just want to make sure we have a brief conversation about it. Partly because this is another one of those good news stories. It'd be nice to leave you all with a couple good news stories on the last day of the class. Yeah, it'd be a good thing. Okay, so let's look at the US and what's been going on with waste generation. So we start in the 60s. And these data go out to about 2015, actually. What's going on here? What might we conclude from this graph? Any thoughts? See red and blue graphs and you cringe a little bit? Is that what's going on? If someone were to ask you, I don't know, on an exam or something, what are the main take-home messages of this graph? What might you point out to them?
Is industry producing more waste? Like, rather than just individual people?
So the per person waste generation, yeah, you know, has been fairly stable for the last 20 years or so. but the total waste generation has gone up. So I should have clarified, thank you. This is municipal solid waste. So this is all like household stuff, but what's happened is the population has increased, is the reason that number's gone up. So yeah, so the total waste generation in the US has more than doubled, right? This is annual. So the total annual waste generation in the US is more than twice that what it was in 1960. So this increased. But when we look at the amount that each person produces, it's been fairly stable since 1990. So we were able to kind of stem that. And we'll talk about why that has been. So what do you think makes up the waste stream, the stuff that goes to the landfills? Any thoughts? What do you think the biggest categories of stuff are? What was that? Food, What else?
Electronics.
Electronics,
Textiles.
Textiles? Good, any other thoughts? So it's interesting. So this is before recycling. So paper, right, is the largest proportion of the US waste stream before recycling and compost, followed by food scraps. So first paper, food scraps, then yard trimmings. So this is stuff going to the landfill, if that makes sense. That would be going to the landfill, right? So paper, then food scraps, and yard trimmings. Then plastics. Well, when we look at after recycling and composting, food scraps are the largest component of stuff that we send to the landfills. Food scraps followed by plastics. And then paper. So a fair amount of yard trimmings get composted, like I know in our neighborhood, like the city will come and pick that stuff up and take it to a composting facility. So a fair amount of that gets composted. But yeah. So again, and remember we talked about that with agriculture, right? And how we're going to feed like our growing population is like reducing waste is an important piece. So there it is right there, like the largest component going to the landfill is food scraps after you take composting and recycling into account. So I look at that and I think, there's a potential to decrease that a bunch, right? Those are all things like we can recycle paper, plastics, glass, right? So food scraps. So if we want to reduce our waste stream, food scraps would be the place to work on. I wonder with this COVID pandemic, just how much styrofoam and packaging is going to be increased, It's going to be pretty intense. All right. So this is the amount of solid waste set to the municipality. I know I'm hitting you with a lot of figures, but the take-home message here, right, is that the overall solid waste has been increasing, but this brown part is the part that goes to the landfill, and that hasn't decreased. Why? That hasn't increased. Why is that? Where is this waste going?
It's like more recycled now?
Exactly. This red here, there's a lot more of this in 2010 than there was even in 1995, right? So, yeah, we're producing more waste, but we're recycling more, we're composting more. So as a result, the amount that goes to our landfill every year has stayed fairly constant. Now, if you look at it, that's still not a very big piece, right? And we saw earlier, right, that this has to go up because the majority of this is food. This has to go up, but this has increased. And so we've been able to kind of keep that stable by being able to process our waste a little better. So the EPA calls recycling one of the best environmental success stories of the late 20th century. There, I like to give you guys success stories. And you don't need to write all this down, but these are just recycling rates that vary among different products. And sorry, I need to make this a lot bigger. But if we look at certain things, for instance, lead acid batteries are at almost 100% recyclability. Because, when you buy a new battery, like, they'll take your old battery and they recycle it for you, right? So some things we're really good at recycling. These lead acid batteries recycle about 100%. But then we look at certain types of plastics, and we're down around 20% or so. So we're definitely better at recycling. So we still have room to improve in recycling. When I was a kid growing up, they used to have a 5-cent deposit on all like aluminum bottles. And so like me and my friends would like go out in the woods and like the roadsides and just look for those cans to like make some money. Like you come back with like a couple of trash bags full of cans and you'd have like 20 or 30 bucks. It's pretty awesome. So when there's incentive, we recycle at high rates. But when there's not, we're at maybe at 20% of recycling. So it varies a lot. So some kinds of plastics, it's down near 6%. This is as a whole is a little bit higher, but yeah. So it just kind of varies. That's the point I wanted to make. So recycling is really helping us out, but it just depends on what we recycle. Cool. Well, it's kind of a happy story. Although you wouldn't know it from this picture. This is Versova Beach in Mumbai. It used to be called Bombay, but it's now Mumbai. And I hope this story makes you happy. It makes me happy. It's all right.
Started October 26, 2015. Almost nearly 43 now, 10 months down the line. And I remember, I live right on the ocean, and when you see the ocean from my balcony, I could see plastics and plastics and plastics. I used to every day open my balcony and see it. And somewhere it ticked my head, the oceans are not healthy, there's a problem in hand. But actually I didn't know what to do. I mean, generally in India, if there's a problem, you approach the government, you approach the local municipality. But I said they have not been doing for 70 years now, so it's obvious, you could see this is something happening. So I decided in my head that I'm going to wear gloves and come on the beach. So 2 became 3, 3 became 4, 4 became more, and now we are here in League 43 with more than 200 people. And they're all regular volunteers. Mind you, this is not like an event happening on a Saturday and Sunday, where people will just come in the next Saturday, Sunday. We have a huge WhatsApp group, everybody's on, and we are all ocean lovers to the core. And that's why we are sticking like a glue for so long.
Can you see the film? If we don't remove, who's going to remove it? As a citizen, I think somebody has to take a lead. If we start, I'm sure more residents of Versova will come up. And along with BMC's help, we are trying to clear it in the maximum.
Project. BMC and the local MLA is also aware. The ultimate goal is to change the mindset of the holy people here in this village.
So there are 19 beaches in Bombay. I'm working on one beach. Our whole group is working on beach. I would want this model to be replicated throughout 18 beaches. In fact, I'm getting phone calls from different localities, and we are actually, my group, whole group VRVs are basing up to make sure that this model is replicated all over Mumbai.
BRB is probably bigger. There's another one called Beacho Beach. And Beacho Beach is also, like I was saying, they go around to different beaches, Versova, Juhu. They go to schools and they're starting some new things with schools.
Clean, decent environment is the only heritage which you're going to pass to the next generation. I hold it in trust for the next generation. And if you are not going to do it now, it will never happen. This is the time, this is now. I would request on Mumbaika that if they can replicate this model all over 19 beaches.
Our citizens have to be alert and they have to wake up. It's not only blaming BMC, it's our habits. We are dumping things here, we are not putting things in the. If you want Swachh Abhiyan, start it from right today.
If you have
So I feel like waste management is one of those things where, like, I don't know, it just feels so good to like get involved in a cleanup. Has anybody ever done like a stream cleanup or something like that? It's pretty awesome. But so this beach, this is what it looked like when they were done, right? This is what it looked like initially. This is what the beach looked like when they were done. It's incredible. And what was really neat about it was this endangered species called the olive ridley sea turtle used to nest on that beach, but hadn't for a long time because it just hadn't been suitable for them. And then after 20 years, they came back. And so it's kind of cute when the baby turtles are headed back to the ocean, like people come out and kind of protect them, you know, too. So it's just a really neat way of, or story of people getting connected with their ecosystem. And I love this too, because we see in so many occasions that really, like, we just have to kind of give nature a break, right? We just kind of have to remove the stressors that are keeping things from working properly. And these natural ecosystems are resilient. In a lot of cases, they'll come back, and we'll find species that used to live there find their way back again. So, so pretty cool. Although interesting, a postscript to this story, it turned out that most of the plastic is coming from a river that's nearby. And so they realized that the plastic was just coming back to the beach. So they took the next step, which was to kind of work with people living in the watershed of this river to try to reduce waste. It was kind of cool. So there are a couple organizations in Asheville that organize cleanups and do this, you know, in a socially distanced, you know, COVID pandemic friendly way. So those of y'all that are interested there, those are good organizations to get in touch with. They do some really neat work around Nashville. Canoes and kayaks, you get in and go do it. It's a lot of fun. Cool. So I just wanted to kind of provide just a couple kind of parting thoughts from my side, and I'm happy to hear, you know, what your thoughts are as well, you know, because this is a very big picture course, and I think it has a few themes that kind of run through it that are important to keep in mind when we look at sort of like the need for change, like how these problems came to be and those sorts of things. And so one quote that I like is that, you know, every time you spend money, you're casting a vote for the kind of world you want, you know? We know that supply adjusts to meet demand, right? And so as consumers in a capitalist society, we're creating demand every time we choose to purchase something. And I know that you're at a point in your life where sometimes you have to purchase what's cheapest. You don't always have the ability to buy something that is more expensive but might be you know, better for the environment or whatever. But wherever possible, think through our environmental issues of this course and think about how consumerism affects it, right? Buying things with less packaging, right? Buying things that are more local. So think about the things that we buy. There have been studies done over and over that have shown us that acquiring more stuff is not the secret to human happiness. What these studies generally show is that, yes, we need to have enough to eat, right? We need to have food security. We need to have a roof over our heads. But beyond that, acquiring more and more stuff does not make us happier. In fact, it does the opposite. And so I think that when we look at finding solutions to our environmental problems, part of that has to come with the realization of what ultimately makes us happy, because so much of consumerism is predicated on we need to do it to make us happy, right? And there's a whole industry of advertising whose job is to make us think that we need things that we didn't even know about before, right? There's a real interesting video that we watch sometimes that we didn't get to this semester called The Story of Stuff. Has anybody watched it? Really neat video, about 10, 15 minutes long, and really just kind of lays out how societies have become focused on stuff, right? And this idea that more stuff is going to make us happier, when in fact, it's really not true. Another theme that I think kind of resonates through this course is that these are global problems that we're struggling with. And when we're struggling with global problems, they require global solutions. I think climate change is kind of, you know, the most extreme case of this, right? Where until developing countries value people in the more until developed countries, the most economically powerful countries, value people in less economically powerful countries equally, there's just not incentive to try and solve this problem. And so our ability to solve these global problems is largely going to have to do with us being able to eliminate the barriers that stay between us as people, right? That as long as we keep drawing lines between us based on, you know, race, creed, color, and all these things, as long as we see an other, then we might be okay with the other suffering more than we are, right? And certainly, there's lots of injustice that has resulted because of this, right? So we can't just say everybody's equal and go from here. We have to try to resolve these inequities which have been in place for so long. And this partly goes back to that article, if you remember, we read at the beginning of the semester. Racism is killing the planet, right? That pollution generally doesn't happen if it ends up in the polluter's backyard, because you see the problem. But when we have these sacrifice zones where there are people that are valued a little less, and they're in the places where we have the cost being paid, whether it's villagers in the Ganges Delta in Bangladesh as water levels rise, whether it's subsistence farmers in sub-Saharan Africa as the frequency of drought increases, folks are paying the price for, in this case, climate change that's being driven by increasingly consumer societies where we are. So when we start to solve some of these issues, this is a quote that, you know, we all have different spiritual, religious philosophies and backgrounds, but this is a quote that really speaks to me. It says, "The well-being of mankind, its peace and security are unattainable unless and until its unity is firmly established." So this idea that, like, we need to value our family members, right, equally. And what about our family, right? What does science say, right, about our human family? It turns out that humans have a lot less genetic variation than most species. The genetic variation, like, between the most two distantly related individuals on the planet is about 0.1%, which is hardly anything. So biologically speaking, we essentially are one family. So it's one of those nice confluences where science and ethics and all sorts of other things point us in the same direction, right? Which is that we are one human family. So this is your family tree. This is relatedness of different people in different parts of the world. And I think one of the themes that runs through this course is that to solve these issues, we're going to have to collaborate with people of all different backgrounds and ideas, and that we'll see the need to solve those problems when we start to feel compassion for people that are very different from us in very different parts of the world, or in our same town, that might be sort of suffering the brunt of these issues to different degrees. So anyway, I haven't taught this class many times, and being an environmental scientist for many years, I think these are just themes that are up here front and center that we just kind of have to acknowledge. So, yeah, anybody have any questions, thoughts, or comments? Yeah.
As like the average American citizen, what do you think is like the thing that Americans need to give up the most to help with like global
That's a really good question. I mean, I guess, I think probably the easiest change so there's all sorts of things we could do, right? Like we could not heat our home, we could only take public transportation, all these things. To me, I think the easiest thing to do at first is related to diet. Like, and I don't mean going all vegan starting tomorrow. I just mean, you know, maybe eating a little bit less red meat, right? A little less meat, because that will start to release pressures on resources globally, because that comes from all over the world. I think that's about the simplest and easiest, and it's something that you can do. I don't even know how things are at Brown right now, like, but when you're at the cafeteria, like the selections you make, like we could change that this afternoon. And then I think we can do it, and it requires some planning and things, but I think that's really the other one. But I guess the biggest overarching thing is just detaching ourselves from this materialism, this idea that like we have to get more and more stuff to be happy, and finding ways to interject that into conversations with friends and family. You know, that the earth is not an infinite pile of resources, and that we're going to run out of things eventually, and that doesn't make us happy. That what makes us happy, right? Relationships with people. What makes me happiest is getting to know people that are different from I am and learning about kind of what they're doing in life, right? So I think just having this mind shift of happiness is coming from materialism to coming from like relationships, and feeling that like amazing feeling of collaborating with someone that comes from a very different place from you, and like learning from that. So that's a long answer, and I think probably everyone in this room might come up with a different answer for what they would like to do. But, you know, these environmental issues are ultimately going to face all of us, like whatever our major is. So it's important to kind of keep that in mind. Yeah, I don't know. Other thoughts on that question? I've been talking a lot. What do y'all see as things that we can do to help with these environmental issues? Any thoughts? It's tricky, right? Because we're not really feeling the brunt of a lot of these issues necessarily. So change has to come voluntarily rather than being forced right now, right? Yeah.
This may be something like insignificantly small, but my roommates and I, whenever we go anywhere out to eat, we always get extra sauce packets, and then we keep them in our fridge, so we never really have to buy a bottle of ketchup. And rather than just having the sauce packets that we would throw away because we didn't use them, we keep them and use them.
So that's a good point. If there's something that were to get thrown out, if you can use that instead, that's great, right? And then thinking about like, yeah, so I guess you wonder too, like a bottle of ketchup, like where the glass could be reused and recycled versus like, yeah, like disposable packets that get thrown out. Like if they give you the packets, and you know they're going to get thrown out if you don't use them, then like bringing them home is awesome. But if I grab like a handful of ketchup out of the
Or just like the extra ones that we don't use.
Yeah, yep, awesome.
We always make sure to keep them.
That's
We're broke.
yeah, yep, that's awesome. Yep, that's really awesome. And like, and see, like things like that, you know, we think, oh, it's something tiny, doesn't make a big difference, but really the difference is in our minds. And so little things like that start to shift the way that we look at things, and then we find other ways that we can, yeah, make some. So yeah, that's right. That just represents like a mindset which we need to have, right? Yeah, it's cool. Yeah, all right. So I have the review sheet for our final exam up on Moodle. I'll have this lecture posted up by the end of the day today. If you want to take the final at an earlier date, just let me know by the end of the day today. Oh, one thing. Please go online and fill out evaluations, teaching evaluations, because we really learn a lot from those and want to know what you like about the class, what you don't, what worked well, what didn't. So please, I know it's like one more thing to do in the week when like everything is happening, but yeah, if you can just take 5 minutes to do that, that would really be valuable. So I'd appreciate that. Yeah, question. Well, so by me, by my department chair, like when they evaluate every year, and even by like university level folks, like when you apply for promotions or stuff like that. So yeah, it means a lot. Yeah, UNCA takes them seriously.
I have other professors that I'm like, I want to make sure that people are reading what I'm writing except for just the.
Yeah, and they will definitely. I think that's it. Well, I've really enjoyed the semester. It's been a lot different than most semesters, but I really appreciate how y'all were engaged and talking, even though sometimes I couldn't tell who was talking because of like masks and like plexiglass things. It's been a lot of fun, and so I'll see you, of course, for our final exam. But beyond that, yeah, just stop by anytime. Don't be a stranger. If you got questions, let me know. If you see me walking around campus and have a fish mask on, be like, hey, how's it going? And yeah, because that's what UNC is about, like getting to know people. So awesome. Cool. Best of luck with finals and all your other assignments, and going home and getting some rest afterwards.
Thank you, Dr. Gillette.
Yeah, thank you all. Appreciate it.